problems that we're going to look at today, there are a couple of just kind of vocabulary ideas that we need to understand to solve these problems. We've already looked at a couple story problems here and there, but in these ones, we're going to have the terms angle of elevation or angle of depression. I have a bunch of yellow.
Oh, thank you. I have the color code thing, so I'm
Like the same color that I do. Is that why you need blue?
No.
Okay.
Math is blue.
Oh, math. Okay.
English is yellow. Biology, like science, is orange.
What? That is not natural. No.
And then, or it's green. But then, like history and stuff.
Okay, so this year,
You told me that orange because it
Alright. So,
last
angle of elevation is just the angle at which we are looking up at something. So in this picture up here, okay, you want to think about your line of sight looking straight forward, and then the angle if you look up. Okay, so you're looking straight forward and then look up. That angle that's created is the angle of elevation. So if we're modeling these situations with a right triangle, it's going to be this angle here that's looking up at the height of the right triangle. Right? So, if we take a look at this first example, it says Casey sights the top of an 84-foot tall lighthouse at an angle of elevation of 58 degrees. Casey is 6 feet tall. How far is he standing from the base of the lighthouse? Okay, so in this problem, right, it says that the angle of elevation from Casey is 58 degrees. So this angle here is going to be 58 degrees. The entire height of the lighthouse is 84 feet. Right, so this whole height here is 84 feet. But what makes this problem a little bit different from things that we've done before is that we're saying Casey is 6 feet tall. Okay? So this height right here from Casey's, we're assuming it's from Casey's line of sight, right? We're assuming he doesn't have a forehead. His eyes are at the very top of his head. So this distance here is 6 feet. What that means is this right triangle that I'm actually going to be looking at is going to be 84 minus 6. This side of the right triangle here that I know is going to be 78 feet. Okay, we're just taking the entire height of the lighthouse minus Casey's height to get this side of the right triangle in this problem. Okay? Now, what we want to solve for is how far Casey is standing from the base of the lighthouse. So looking at this right triangle, that's going to be this side right here. So that's my x, and that's what I want to find. So once we have this set up, this is just like what we've been solving. Right? The only new part is drawing the picture and figuring out what we have to solve for. So now, with respect to this angle, we can say the two sides that I have information on are the opposite side and the adjacent side. So that trig function is going to be tangent. So we'll say tangent of 58 degrees equals 78 over x, opposite over adjacent. So this is one where we have x in the denominator. Solve, multiply the x over, divide both sides by the tangent 58 degrees. And we can put that into the calculator. 78 divided by the tangent of 58. And again, make sure that your calculator is in degree mode. 48.7. The directions here say round to the nearest tenth. So just double check what the directions say. Yeah, so 48.7.
I think we should use the rate calculators instead of these.
Why's that?
I like them better.
So 48.7 feet would be my answer here.
My state valley says we use this rate calculator for the rest of our life. They had us buy one like in 6th grade. Using those, we have to use for the rest of our lives.
This rep calculator you can use for every high school and college math class you'll ever take.
What else do we need? We're good on that.
Who told you that? Oh, they lied to you.
They're too expensive. You don't need them. You just use the red ones.
I mean, that's true for like middle school, but once you get to high school, you need a graphic calculator. You can't use that on the test.
Why not? Very professional. Those like secure lockdown routers.
All right. Any questions on this first example here?
I got 9.
Are you in the right mode? Press mode. See if degree is highlighted. What?
Okay, go to
The
down.
third line down.
I still have this.
All right, let's take a look at one more together here. So on number 2, it says the angle of elevation from a kicker's foot on the football field to the top of the goalpost is 17 degrees. He's standing 131 feet from the base of the goalpost. We want to figure out how tall the goalpost is. So in this case, we don't have that little extra height that we did in the first problem, right? Because we're talking about somebody's foot, not their line of sight. So this is the bottom of my triangle is the ground. The angle of elevation is 17 degrees. And this person is standing 131 feet from the base of the goalpost. So here's the goalpost. Here's the kicker. Our goal is to figure out the height of the goalpost. So this would be our setup for this problem. So again, we're going to use tangent because I'm dealing with the opposite and the adjacent sides. So our setup would be tangent of 17 degrees equals opposite over adjacent, so x over 131. And to get x by itself, all we need to do is multiply both sides by 131. We can put that into the calculator. 17. We get 40.05. So it would be 40.1 if we round to the nearest tenth. Yeah. But I guess we are given units, so I should have labeled feet. I know, it's pretty awful. 40-foot tall goalpost.
Yeah, that's pretty bad.
Wait, we didn't have any information about whether he made the field goal or not.
I just said it was pretty bad. It means it's not that high. You gotta get way over there.
The goal of kicking a field goal isn't to kick it high, it's to kick it through the goalpost.
question is, what did I do wrong here?
You would have to close the parentheses.
Okay.
Yeah, so you told it to do tangent of some humongous number.
Okay.
Alright, questions? Alright, why don't you guys try 3 and 4 then?
I don't really remember
You have to find the angle, right?
Just divide by 6. I have a question. So what is, like, in your table,
What do you have to do? We do it backwards. Oh, wait, never mind. I know what to do. We can make a sign of X.
Oh my god.
Then we have to do the inverse of sign.
Over.
Yay!
Fach.
Once we get to that, I think
So
Wait, what do I do from here? I inverse both sides. So what would be the inverse? Times 16 divided by 5.
the inverse tan.
So,
16.
Oh,
remember,
is it 10?
you got 12.5?
yes.
I know, I was defaulted.
9.
Wait, what do I put in that though?
Now you put in 16 divided by 5.
Into the angle part?
Well, yeah, because you're putting in the sine action, right? You're putting in
No.
that's why we use the inverse.
I get that.
Wait, what did you get for 4? Okay.
Oh. Is there to win the debate? Wait, what are the chances of me winning? Like 70 or 20, I mean?
I give right now. I give you like 60.
60? Dang, it's harsh.
Between 60 and 70.
As of right now. What about after today? Is it 100?
Well, if that's what we decide.
What? What was that? I mean, you helped me write the whole thing, so you better know.
That's how that works.
Oh, shut up. Nick's doing the closing statement.
Henry's not doing the closing games.
I'm not gonna let him, I'll tell you that much.
Alright.
I need that.
We should have gotten 12.5 feet for number 3. And then number 4, we were solving for the angle. So 72.6 degrees for this one. What questions do we have? So you guys All right. Questions on these two? All right, then let's flip over to the back and talk about angles of depression. So, an angle of depression just occurs when you are looking down on something, right? So, again, just like an angle of elevation, we want to think about looking straight ahead, right? And if you're looking up, it's an angle of elevation. If you're looking down, it's an angle of depression.
There's nothing negative on the right.
No, we're not going to put a negative anywhere. So, in a picture like this, right, if we got a lifeguard sitting up high, the angle of depression would be the angle that he's looking down at a swimmer in the water. So if we're told that his angle of depression is 27 degrees, that would be this angle up here. Okay?
always not 90.
So this entire angle here would always be 90, yes.
Okay.
So yeah, if you wanted to get this angle inside of a triangle over here, you would do 90 minus 27.
Will it always be right triangles though?
Yeah, all this stuff is just right triangles.
On the other angle. So,
If you need to, yeah, you could. So let's take a look at number 5. Number 5 is modeling with this picture here. So it says a lifeguard is sitting on a platform, looking down at a swimmer in the water. The lifeguard's line of sight is 8 feet above the ground. Okay, so that means that from the ground up to here is 8 feet. His angle of depression is 18 degrees. So this angle right here is 18 degrees. Now, our goal is to find how far away the swimmer is from the lifeguard. So this question, when it's worded like this, can actually be a little bit ambiguous. Usually what it's actually asking is for this distance, right? The way it's worded though, it kind of makes you think that it wants this distance, okay? So on a couple of these questions, the way it's worded can be a little ambiguous. But on this one, I think what it's actually asking, how far away is the swimmer from the lifeguard, is for this piece of information. Okay, so we actually can draw our triangle one of two ways. We can either say, well, I want to look at this triangle here. So this is a right triangle. I know this side's 8, this side is x. And then if this angle is 18 degrees, we could say, well, these two add to 90, so this angle would be 72. Or, without doing any math, we could just say, well, the line of sight is parallel with the ground, which means these two angles would be alternate interior angles. So this one's 18, this one's 18. Right? Now, we could also, instead of doing that, we could just draw an upside down triangle. Right? So instead of using this triangle here, we could draw a triangle like this. Right? And say, well, if this side's 8, this side's 8, and this distance from the swimmer to the base of the lifeguard would be the same as that distance. So I could use this triangle. Okay? It'll be the exact same triangle. So we have a couple options when we're sketching out our figure. Well, no, I'm not making another triangle. I'm saying we could have done this first instead of this.
Oh, okay.
Yeah, it wouldn't make sense to draw both of them. You could use either of these triangles to set up your problem. Okay? So, to finish this one out then, right, with respect to this 18 degrees, this would be the opposite side and the adjacent side. So we will have tangent of 18 degrees equals opposite over adjacent. Multiply both sides by x, and then divide by tangent. What is it? 24.6. Did we have units? Feet. Okay, so I guess one way to clear up the ambiguity on whether you're solving for this side or this side would be to think, how is this lifeguard going to get to that swimmer? Is he going to fly along this line, or is he going to have to get out of the chair and go along the ground? Right? Probably not from the top of the chair.
I did tangent of 72 degrees equals x over 8, but I got that same answer.
Yeah, that would absolutely work. because if we use this angle here, we say this angle is 72 degrees, then with respect to this angle, this is the opposite side, and this is the adjacent side. So you could say tangent of 72 equals x over 8. And then multiplying by 8, we'll get the exact same answer. Yep, that would absolutely work. Right. Questions? Okay, so I think there's another problem down here somewhere where there's something flying, like a bird is at the top of a post, and they ask, how far is the bird away from an animal down here? In that case, since the bird can fly directly along that line, we would solve for that piece of information. Right? So
How do we know which one's solved? It's just like not really the animal, or it's just like two objects that what is called have. You know what I'm saying?
So there usually there's not going to be that ambiguity. Okay, so like for number 6, it says what's the altitude of the helicopter? That tells you you're solving for the height. Right? For number 7, how far apart are the buildings? Right? So you're finding this distance between buildings. So there isn't usually going to be that ambiguity. Right? Just if that does ever come up, you're just trying to think, well, can this object follow this path or this path? Sure. Right. Do we want to try another one together, or do you guys think you can try a couple? All right. Why don't you guys try a couple? All right. I will be right there. All right. Take a look up here. Here are the answers for 6, 7, and 8. What questions do we have? I think the only tricky one, was number 7, where we were looking at 2 buildings. Right, so the one was 480 feet, the other one was 654 feet. And it just says the angle of depression from the top of one of them to the top of the other is 42 degrees. So we had to look at just that side of the right triangle in question is 174 feet. So no questions on those? Alright, here is the homework. Right, it's on a piece of paper.